so we move to the last subtopic in Module 1, Chapter 1, Modular Arithmetic. So let's see. Alright, so what is the motivations of modular arithmetic? Okay, so in some situations, we care only about the remainder of an integer when it is divided by the positive integer. Okay, so let's see the examples. For your understanding, if the time is now 9 o'clock, and what will be 100 hours later? Okay, so we can use the remainder to find the answer. Alright, so consider n is equal to 24. Why 24? Because we have 24 hours per day. Okay, and our dividend is 9 o'clock. Okay, 9 o'clock right now, and plus 100 hours later, so you have a 109 hours. Okay, then we use a division algorithm. Okay, do you remember what is the division algorithm? It is m is equal to qn plus r. Okay, so m109 divided by 24 quotient 4. Okay, remember you got 13, so it is in 100 hours later, it will be 13 o'clock from 9 from now. Okay, so pukul 1 lah, 1 p.m. Okay, so division algorithm. Okay, let's recall. R is equal to m mod n. Okay, R is equal to m mod n. R is 13. So mod is 109. M is 109 mod 20, 24. Okay, so another example. Okay, evaluate these identities, these quantities. Okay, given that 17 mod 3, we know that R is equal to 17 mod 3. If we are given 17 mod 3, actually we want to find what is R. Okay, so 17 is your dividend, and 3 is your n. Okay, we use division algorithm, which is m is equal to qn plus r. M is 17, q is n is 3. Okay, so 17 divided by 3, 5 times 3, 17 plus 5 times 3, 15 times plus 2, you got 17. So R is 2. So, okay. Alright, so let's see B. B ni mungkin student tend to do a careless mistake. Why? Because you have negative. And always bear in your mind your remainder should be greater than or equal to 0 and less than your n. Okay, here this is your m, negative 133, your n is 9. So negative 133 divided by 9. Okay, so you got, you take negative 15. Okay. Okay, take negative 15 times 9. Okay, you got negative 135. So minus here. So negative 135 minus negative negative 133 minus negative 135. You got 2 here. Here is negative 15. Okay. So see, can you see the remainder is 2, which is greater than or equal to 0 and less than 9. Okay. Alright. Okay. So you may try this exercise for your understanding. Okay. Alright. So let's see congruence. Okay. Congruence is very important. Kita akan banyak guna after this. Okay. So given the division algorithm, M is equal to Qn plus R. So how to determine whether it is a congruent or not? So is M congruent to R mod N? Okay, kalau congruent, memang kita tulis macam ni. So this is a symbol of congruent. 3 simbol. Okay, this is congruent. Okay, dia bukan equal sign, tapi this one we read as congruent. M congruent to R mod N. Okay, how to determine whether M congruent to R mod N? So when N divides M minus R. Okay, when N divides M minus R, so we say that M congruent to R mod N. Okay. So this one you can also write as, after this, okay, we will see, okay, this kind of a notation. Okay, M congruent to R mod N. So M mod N is also equal to R mod N. M mod N equal to R mod N. Okay, so next, okay, if N does not divide M minus R, then we say that M does not congruent to R mod N. Dia mesti N divides M minus R. If not, M does not congruent to R mod N. Okay? Alright, so let's see the example. This one, 29. Okay, 29. Okay, 29. M and your N is 5. Okay, so you got 4 as a remainder. So you can check whether 29 congruent to 4 mod 5. Okay, so N divides M minus R. So N is 5 divides 29. M, R is 4. So 5 divides 25, right? So 29 congruent to, okay, 4 mod 5. Okay, same goes to this one. 3 divides, M is 3, N is 6, yeah. So remainder is 3, okay. So congruent or not? Congruent is if N divide M minus R, N is 6, M is 3, okay, R is 3. Is 6 divide 0? Yes, 6 divide 0. So, right, so M3 congruent to R3 mod 6, okay? Alright, so let's see the example. Determine whether 17 is congruent to 5 modular 6. Okay, determine whether 17 is congruent to 5 modular 6. If you transform into this form, okay, if you transform into this form, you can write it as a 17 congruent to 5 mod 6, yeah. Okay, so how? So you have to do the division algorithm lah. Okay, 17. Okay, you have to check. N divides M minus R. N is 6. M is 17 minus R 5. So 6 divide 12, therefore Okay, 17 congruence to 5 mod 6. Okay. Right, so second one, determine whether 24 is congruent to 14 modular 6. Okay, determine whether 24 is 24 congruent to 14 mod 6. Okay, so n divides m minus r. Okay, n is 6. Okay, so m is 24 minus r 14. So is 6 divide 10? No, 6 does not divide 10. Okay, and again, what does it mean by divides? Okay, what is divide? Okay, divides mean, okay, the remainder is 0. It is completely divides. Okay, means that the remainder is 0. If the remainder is 1, if the remainder is still integer, still it does not divide. Divides means you completely divide, you got the remainder is 0. Okay. Okay, so next. Okay, exercise you may try. Okay, so we go to mod n function. Mod n function, Cn. Okay, so for each n in positive integer, any positive integer, again, I repeat what is positive integer. Positive integer start from 1, 2, 3, 4 until positive infinity. So we define the function, okay, mod n function. This is the mod n function as follows. Okay, so mod n function, it is a fn. Sec is equal to r. Okay, what is this? Again, this is mod n functions. F stand for functional. Okay, Z ni apa? What is Z? We define here what is Z. Okay, we define here what is Z. Okay, so R must be greater than or equal to 0, less than n, yeah. So Z is R mod n. Okay, so let's see this one. F mod 3 function, mod 3 function F 316 is equal to 1. How you get 1? Okay, how you get 1? This is actually okay, you obtain from here. Okay, this is your n, right? Because we have f and z. So 16 is your z. What is 1? 1 is r. So how you got it? Okay, it is actually like this. If you write here, it is actually, this one should be 3. Sorry, should be 3. Right? Okay. So it is actually 16 congruence to R is 1 mod 3. Why? Because set congruence to R mod n. So can you see here? Set is 16, R is 1, n is 3. So 16 congruence to 1 mod 3. How you get this? Because okay, we use a division algorithm. M is equal to Qn plus R. M is 16 equal to, okay, N is 3. So 5 times 3, 15 plus 1 equal to 16. So can you see the remainder is 1. Okay. How you know it is a congruent? Now you can check. M n divides M minus R. Okay, N is 3 divides 16 is M. R is 1 minus 1. 16 minus 1, 15. So of course 3 divides 15. Yeah. Okay. So this one we move to the F2. Okay. F7 156 equal to 2. Why? Okay, this is because of, so saya delete this one supaya you senang nampak. Okay, right. So this is because of, okay, 156 is equal to quotient times 7 plus remainder. Okay, so apa yang you boleh tulis sini? So 156 congruence to, what is remainder? Remainder 2 mod 7. Okay, 156 congruence to 2 mod 7. How about F314? Okay, so 14 is a 4 times 3 plus 2. So it is a 14 congruence to remainder 2 mod n, which is a mod 3. Okay, so mesti tell lah sini 7, kat bawah ni mesti 7 as well. Here 3, bawah ni pun mesti 3. And F7153 6. Okay, so ni macam mana? Okay, ini pun sama. Okay, 153 equal to, here 7. Okay, 7 times 1. Okay, 7 times what? You got here is 20, 21. Okay, so 21 times 7, 147 minus 153, but 6. So it is actually a common operation saja. 21 times 7, 147 plus 6, so you got 153. Okay, matematik biasa saja, common mathematics lah. So y6, okay, because the remainder is 6, so okay, 153 congruence to, okay, 6 mod 7. Okay, that is a mod n function. Okay, so try to do the exercise. Okay, so let's see another example for your understanding. Okay, if f is the mod 7 function, okay, solve f z2. Okay, so f is the mod 7 function, solve f z equal to 2. So f7 z equal to 2. So it is z congruence to 2 mod 7. Okay, this is a remainder. So z congruence to r mod n. Okay, so if you write it, it is if you write it in a division algorithm, okay, z is equal to something qn plus r. Qn is 7 plus r. Okay, this one adalah division algorithm lah. So our z is your m actually. Okay, division algorithm, m is equal to qn plus r. Ini kita panggil congruent, which is a modular arithmetic lah. This one division algorithm means that you are going to use a division algorithm throughout this chapter. Okay. Alright, so we are going to solve f z is equal to 2. We are going to find the possible solutions of f z equal to 2. Okay, so from here, if q, we don't know what is q, but q plus q times 7 plus 2. Okay, q is a 0. Okay, so z equal to 0 times 7 plus 2, so equal to 2. So your z is 2. Okay, if your q is 1, then z equal to 1 times 7 plus 2, which is 9. When q is 2, so z equal to 2 times 7 plus 2 equal to 16. When q is equal to 3, z equal to 3 times 7 plus 2 equal to 23. If a q is equal to 4, then z equal to 4 times 7 plus 2, which is 13. So you can proceed, but I want to stop here. So what can you conclude here? What can you conclude? So we want to find the possible f z is equal to 2. So the solution of f z equal to 2 is 2, 9, 16, 23, 30 until infinity. Okay, so that is the answer. Yeah. Okay, so you may try this exercise, right? Okay, we have another example. Solve 3x congruence to 1 mod 5 if possible. If no solution exists, explain why. Okay, so we have a 3x congruence to 1 mod 5. Okay, solve means that we want to find the unknown. So unknown here is your x. Okay, 3x, we don't know what is x. So we are going to find the unknown x. Okay, so since the modulus, modulus is 5. Yeah, so we want x, okay, in the range of, okay, 0 less than or equal to x less than 5. Means that we want your x in the range of 0, 1, 2, 3, 4 only. Why? Less than 5. So we want your x, okay, in a x such that 0, 1, 2, 3, 4 only. Okay. Alright, so what's next? Okay, so if we take if x is equal to 0, then okay, we know that 3 times x congruence to 1 mod 5, right? Right, so 3 times 0 congruence to 1 mod 5. So what is 3 times 0? 3 times 0, 0 lah. 0 is a 0 congruence to, okay, congruence to, sorry, so ini yang diberi, jadi kita nak cari, okay, 3x0 congruence to what mod 5? 3 times 0, 0. Mod 5 ni means that 0 divided by 5. So what here? 0 isn't it? 0 times 5, 0. Okay, so what is the remainder? 0. Okay, so next, when x is equal to 1, 3 times 1 congruence to remainder mod 5. Okay, 3 mod 5, you got 3. Okay, this is a tips. Okay, this is a tips. When you have a smallest dividend, okay, divided, when you have a smallest dividend divided by divisor, then the remainder is equal to dividend. Again, when you have a dividend, okay, smaller than divisor, then the remainder equal to dividend. Why? 3 divided by 5, so remainder cannot be negative, so quotient 0. 5 times 0, 0, remainder is 3. Can you see? Okay, when the remainder, when the dividend smaller than divisor, then remainder is equal to dividend. Okay, so this is 3. Okay, so tak susah pun. When x is equal to 2, so 3 times 2, 6. Congruence to remainder mod 5. Sorry. So 6 kan? So apa? You ada 6 divided by 5. So 1. Remainder is 1. So when x is equal to 2, okay, 3 times 2 congruence to 1 mod 5. Alright, so when x is equal to 3, so 3 times 3 congruence to what mod 5? Okay, 3 times 3, 9, mod 5, 4. Right? So 9 divided by 5, 1. Okay, 4. Next, x is equal to 4. Okay, so 3 times 4, 12. Congruence to mod 5. Okay, 12 divided by 5. So remainder is 2. Okay. Okay, so can you see where is the answer? We want 3x congruence to 1 mod 5. Kat mana answer dia? When x is equal to 2, Then 6 congruence to 1 mod 5. Okay, sama kan? Alright, so therefore, the only solution to the congruence is x is equal to 2. Okay, so that is the answer. Alright, so this is the exercise. Okay, try to do it. Okay, so we are done on the module 1, which is a chapter 1, number theory. Okay, if you have any question, okay, please do not hesitate to see me. Okay, I'm ready to help you. Alright, so thank you and assalamualaikum. Bye.